Hi guys, welcome to my YouTube channel. Today we'll be learning about the Z parameters from the two-port network theory. The Z parameters of this network is given by V1 is equal to Z11 I1 plus Z12 I2. V2 is equal to Z21 I1 plus Z22 I2. So the Z matrix is given by Z11, Z12, Z21, Z22. This Z matrix is very helpful in determining whatever the load needs to be attached to the uh, right side of the Z block, so that like maximum power is transferred to any load. This is also helpful in solving making equations simpler and also like determining the stability of a network. We are going to solve this gate 2020 question. Here this question appeared in gate 2020 where like the Z parameters were given 40, 60, 60 and 120, and we need to find out ZL for which the maximum power is transferred. uh, there was also like this circuit diagram given, so I'll draw that. Okay, this is V2. This the voltage at the left side of the Z block will be V1. The current entering to the network is I1, and the current entering from the outside is I2. So here the voltage equation will be V1 is equal to 40 I1 plus 60 I2 from the Z matrix that is given. Let this be equation 1. Similarly, V2 is equal to 60 I1 plus 120 I2. Let this be equation number 2. Then we need to find the output impedance ZL. So when is ZL matched? When the input impedance, when we observe the input impedance from here, input impedance becomes equal to ZL. So this is the condition when max power is transferred. We can find ZL using the Thevenin's theorem. So the Thevenin theorem will be given by equivalent resistance RT. Okay, and this is my ZL, Thevenin's voltage plus minus. So when maximum power is transferred, ZL becomes equal to RT, which is the Thevenin's resistance. And Thevenin's resistance is given by open circuit voltage divided by short circuit current. Open circuit voltage is defined when current I2 outside the Z block is 0. Short circuit current is when determined when outside block V2 is short circuited, then we find the short circuit current. So from if we like apply KVL and this loop, like say A, we apply KVL at A, KVL at A loop, so we'll get 120 minus 10I1 is equal to V1. Let this be equation number 3. Open circuit voltage V2 open circuit voltage V2 when I2 is 0 is equal to V1 is equal to 40I1 from the like voltage equation that was written plus 60 into 0. So how much it is? 40I1. Let this be equation 4. Similarly, V2 is equal to 60I1. This is equation 5. Now put equation, substitute equation 3 in equation 4. We get 120I1, 120 minus 10I1 is equal to 40I1. After solving this, we'll get I1 is equal to 12 by 5 amperes. Now my V2 is equal to 60 into 12.5, that is equal to 144 volt. So this is my open circuit voltage. Open circuit voltage VOC. Now we need to calculate the short circuit current. To calculate the short circuit current, we know that ISC can be calculated when V2 is equal to 0, and we need to find the value of I2. So same from the current equation, the Z parameters, we wrote the equations. We'll get 0 is equal to 60I1 plus 120I2. Then I1 is equal to minus 2I2. And we again like substitute. Then let this be equation number 6. Substitute equation 6 in equation number 3. Equation number 3 is what we found with KVL. V1 is equal to 120 minus 10I1, and I1 is minus 2I2. So V1 is equal to minus 80I2 plus 60I2. V1 will be equal to minus 20I2. Okay, now we solve for current I2 actually. Then from the characteristic equation 1, V1 is also equal to 40I1 plus 60I2 from the Z matrix. So we substitute this here. Minus 20I1 is I2 is equal to 40I1 plus 60I2. Again, like I1 can be substituted here as well. I1 is this. So substitute I1 from 6. We'll get minus 20I2 is equal to 120 minus 10 into minus 2I2. So minus 40 I2 is equal to 120 and I2 is equal to minus 3 amperes. So this is my short circuit current ISC. So now we know like the short circuit current, this has a negative sign because we assumed that the current I2 is flowing inside the loop, but actually it is flowing outside. So this is why like I2 is negative here. So now the RT Thevenin's resistance is equal to open circuit voltage divided by short circuit current, that is equal to 144 volt we found, and 3. We are taking mod here because like we assume the current direction was going into the circuit, but actually it is going outside the circuit and resistance can be negative, so positive value is taken here. This is equal to 48 ohms. So we know like when for the maximum power transfer, ZL should be equal to RT. So ZL is equal to RT, that is equal to 48 ohms. Yeah, thank you for like checking out my video. So this is my like first video, and I would like any corrections to be made, and also like any improvements, scope of improvements, all are welcome in the comment section. Please do like and share my video, it would really help me.